So the 1 brings the thing into the number system, and then these two, if we'd have had more money, we could have had 17 screens here and 39 screens there.
More time, I think.
Yeah, and more wire and more electricity. Yeah. And we could be illustrating that 17 plus 39 equals, what is it? 68 or something. No, probably not, 66. And then we could roll this in front of that and show what 17 times 39 equals, except you wouldn't really see them. But
another aspect of this, what this apparatus introduced into the problem was this, that the actual image is degraded. So you do get this notion of abstraction with the repeated application of number.
Yeah.
Which we didn't think about in advance.
No, that's
like an added bonus.
Well, we did a bit in the sense that the feedback system was, we knew that we were getting tiny amounts of information. And
yeah, but to actually see it, I mean, you've got an actual three-dimensional thing here, a reasonably good representation of it, not bad, and then you roll this out, and you just end up with a sort of vague blur. You know what you're looking at, but only because you're referring it back to this. And this reminded me of how these 3 stages of counting, using numbers to count something, which is sort of the most innocent, innocuous use of number, using numbers to add things together, and then using numbers to multiply things. These are different stages in the evolution of how we apply number, and in doing so we remove ourselves further and further from the world we're dealing with. And the best way I could think to explain this, I wrote up a little piece about this earlier today. So if you could imagine a vet operating on a sheep that was in need of medical attention, the actual details of that particular sheep would be evident to that vet. They'd be dealing with a unique creature that's metabolizing and sentient in some form and had its own unique history and characteristics, and how that sheep differed from other sheep would be very, very apparent to the vet. Now, if you've got a shepherd counting their flock to make sure that all the sheep are there, they'd have to register each sheep individually to count. You have to at least register that it's there, otherwise you can't count it. So the individuality of the sheep is further away, but you're sort of, oh, it's that one, okay, that's that one, that's different from the one I just counted over there. So the individuality of the sheep is receding, but it's still present. But if you were a big-scale sheep farmer who had 90 different flocks of sheep in different fields, and they all had 20 sheep, and you were thinking how many sheep you had, you multiply 90 times 20, 1,800 sheep, but the individuality of the sheep's long gone, you're not dealing with them anymore. So it's that degrading of the image. This was an unintended consequence. If we'd been using high quality gear and thinking, designing it in a more effective way, we wouldn't have thought of that.
That is that introduction of the failure of the model
that leads to interesting new insights.
Yeah, and I think that this tracking motion here is actually quite. I was expecting this to be quite sort of clunky, but this creates quite an amazing effect, and it's this sort of this liminal stage between this transition where between these two states.
And this actually poses a mathematical, or possibly a mathematical question. I went out for a walk this afternoon, and I was thinking about this. Scratch videos. I don't know if this is pretty wacky, and I don't know if there's even a valid mathematical question here, but I'd never have even thought to ask this had we not built this, which is, okay, we see what's going on there, 2 plus 3 is 5, we see what's going on here, 2 times 3 is 6, but what's going on in between? Okay, what's going on in between here is clearly, you can explain that in terms of optics and physics, but in terms of metaphor, how do you get from plus to times? Is there anything in between? I've been talking about them all week as these categorically different things. There's addition, there's multiplication, there's this huge leap. But in that leaping, do you pass through anything that you can talk about? Is there some in-between thing whereby addition can be morphed into multiplication? I cannot think of any mathematically coherent way of...
This suggested this other kind of poetic extension of the project which you were talking about earlier, with the cross.
Oh right, then as a result of thinking about that, it occurred to me that one feature of this that we never got around to because it was all a bit rushed was to introduce some sort of mechanism where a user or viewer of this device could pull a handle or turn a crank or something to make these things move back and forth, so they didn't actually have to physically grab hold of it and potentially break it. So we were talking about levers and springs, and then I think Conrad suggested you could just have a disc that you rotated with a rod, and it would move it between these 2 points. But for some reason this afternoon, thinking about that and about this issue of moving between addition and multiplication, it occurred to me, and this is completely arbitrary and has nothing to do with the nature of mathematics itself, but this is a symbol for addition, and that's the symbol for multiplication. So I had this idea that you could have a cross with a handle on it, so it would be a plus sign in this state, and then you turn it a quarter turn, and there'd be a 4:1 gear ratio that would then move it to there. So then it would be a cross, and you'd see multiplication. You turn it to a plus, and again, it's only the fact we've built this that you'd even think about doing that. I mean, that's.
Well, I think that's delightful evidence that there's been some kind of cross-contamination here. And
yeah.
Matthew, perhaps to his great horror, has started to think like an artist. Yeah. So I think it would be great to offer up to the audience now an opportunity to ask any questions about anything we've talked about tonight.
I've been dying to leap in. I'm a very weird sort of historian. So I know the answer to some of your questions as far as history can tell us. Firstly, the connection between the plus sign and the multiplication sign is quite deliberate.
Okay.
That was, I think, done by, I can't remember which, an Arabic, the great Arabic mathematicians, one of whom was algebra, where we get algebra from. I don't know which one it was, but I think that was done by one of them. The other thing was the transition from adding to adding to multiplication happened with farming, because you would count how many sheep. Like you said, how many sheep have I got? I've got 10. I have 10 ewes, 10 female sheep. What if they have twins? How many sheep am I going to get? There's your transition. Because suddenly what were 10 produce much more than that.
Yeah, multiplication in that sense.
That is exactly
this is something that Conrad's been
in that
yeah,
sense.
we didn't really get to it, but there's on this graph is this idea of we had this sort of idea of, in terms of, I've been looking at ways, and a lot of my pieces have this sort of extrusion of time, where time is occupying one of the 3 dimensions and you extrude it through space, you give it a representation. But one of the things we were talking about with this, was one idea that came up is this pistachio nut, which was another nut we were eating in this windowless room for a week. We had a series of, the nuts seemed to form quite a good sort of basis of lots of conversations. But the idea of a timeline of what a pistachio becomes, so you have your pistachio nut here, which then grows into a tree.
Yes.
So then your tree is here,
yes.
And then from that tree comes another nut.
Many of them.
Yeah, well, many of them, but they all basically, if you trace one, it's sort of coming off and forming another tree.
Yeah.
What was that one coming?
This ties up with
reproduction.
So the reproduction, but then there is this sort of idea of germination and reproduction, and where multiplication is how it compares to reproduction, and then sort of perversely you've got the idea of 1 and 1 making 3 rather than 2, because you've got a reproductive element where you're left with 3 entities rather than just that they time together to make something greater than the sum of just the 2 of them.
So it's really fascinating, that kind of poetic association that you forged between this very abstract question and the notion of biological multiplication. In fact, that might have been humans' way into multiplication is precisely through those biological processes.
Yeah, and I suppose one of my things in terms of creating this kind of this failure, this graph that was getting kind of getting into all these incredibly complicated realms, was then to create a parallel kind of world where each of these solaces or these braces or these leases, these names, these symbols of numbers, actually had genders as well. And then it was combinations of both male and female braces and leases that you should have this sort of subtable where you'd have a male sub hawk brace.
You could sort of